Okay, everybody, we are going to head into some adding and subtracting of rational expressions. Let's go ahead and start off with a couple questions today regarding denominators that are not the same. And we want to look and see how do we go about this. So you have to think about how you add and subtract fractions that are just regular numbers. So what I'm going to do is I'm going to take these two denominators and I'm going to use them to rewrite this problem with a common denominator. Now, what you're best off doing is getting what's called the least common denominator. Some people call it the least common multiple. So what I'm going to do is I'm going to take this term right here, and I'm going to multiply it to this term. And that is going to become my, let's redo that. That is going to become my common denominator. All right, now, the way this works is you have to compare the old denominator to the new to determine what the new numerator is going to be. So let's go ahead and do that. So let's look at this denominator and let's compare it to this denominator. What do you see that's different? Well, we see that the x plus 3 is different, right? So what we want to do then is we want to take this 6 right here and we want to multiply it by x plus 3. Now, if we take a look at this carefully, you notice that if we removed this common factor from both, you see how you have the original fraction, 6 over x? So it's kind of like unreducing a fraction. That's the way this works. So now, let's look at the other denominator over here and compare it to the original denominator. What do you notice that's different? Okay, you notice that
staff and students, we are apparently still working on the problem with student Chromebooks. There's a few thousand Chromebooks in the district that are not working, so be patient. Students try to restart them and give them some time and try again. So teachers obviously accommodate this, and we are working on it as a district. Thank you.
Okay, those of you listening at home, you'll notice that we had a little interruption there. But I took my numerator 5 and multiplied it by what was different. So if I were to look at these two fractions and take away what's common to them, which is what we put in there, you can see that you have that same fraction, 5x or 5 over x plus 3. So now that we have common denominators, what we can do is we can go ahead and finish this problem. So this problem will be a common denominator of x times x plus 3. And if we move up here, we can do a little distributive property on this. It would be 6x plus 18. So we can pretend that's not there. And basically going to combine like terms here. So what I see is I've got a 6x and a 5x. Well, that would be x, right? And then you have the plus 18. And there's your final answer. Do not be tempted to cancel out any x's. They need to be factors in the numerator or denominator to be able to do that. All right, so that's an explanation of how these done. Let's do a couple more. All right, everybody, let's go ahead and rewrite this as two new fractions. So the question is, what should the denominator be? Now keep in mind, you've got these two denominators which are different than one another, right? So I'm thinking what we need to do is have one denominator that's x plus 2, and the other denominator x minus 1. And you might be thinking, well, I guess I could just multiply the two denominators together to get a common denominator. And yes, that's true. Now, eventually we will see questions where that might be actually a little bit too much to work with. So you might want to trim it down and go for what's called a least common multiple. But anyway, let's go ahead and look at our fractions now. So what I'd like everyone to do is look at this denominator versus this. And what do you notice that's different? The x minus 1, right? And then we have this 6 goes in there. Now let's move to this. There's a denominator. Let's compare that to this one. And what's different? Well, the x plus 2 is, right? And the numerator is a 7. Now, once again, I mean, if you were to take away those common terms, you would see that you were left with the original fraction. So you've basically unreduced these fractions. So our answer should be the denominator of that. We need to do a little distributive property here. So that'd be 6x minus 6. So don't look at that anymore. Then here's 7x plus 14. And now it's a matter of just combining like terms. So the x's give you 13x, and negative 6 plus 14 is positive 8. And there we are. So basically reteaching how to add and subtract fractions. But these are rational expressions. Let's try another. Okay, let's see if you have the hang of this one. All right, so we've got this term. And you've got this denominator. All right. We have these two numerators, which will be there. Just gonna multiply them to something else. So what we gotta do is compare things, right? Let's make a comparison. Look at this versus that denominator. What do you notice is different? The x plus 4 is, right? How about that denominator versus that one? What do you notice is different? The x. I think it's time to go ahead and finish this problem. So our denominator will be x times x plus 4. Excuse me. Let's do a distributive property. It'd be 3x plus 12. So let's not look at that anymore. And then you got 2x over there. So add your x's. Do not be tempted to try to cancel any of those x's because 5x and 12 are being added, not multiplied. All right, let's give this a try. Gotta be a little bit careful with this because we have a subtraction problem now, so it's slightly different. So what's our other denominator? It's a 4x, right? I guess you can put parentheses around that if you like. Now we got to look at our numerators. So we have an x, and we have an x minus 3. Now watch this. Or group that in parentheses. Let's take a look at our denominators, make a comparison. So there's our first. Here's our next. What do you notice is different? The 4x, right? So I'll multiply that by 4x. Compare denominators. What do you notice is different? 2x minus 9, right? All right, now we have a little bit more algebra to do in this case, so I might write this out in 2 steps. I think I'm going to do a lot of simplifying here, okay, everyone? All right, so first of all, first one is 4x squared, isn't it? Over here, we got to do a FOIL method, so it'd be 2x squared minus 9x minus 6x. So that'd be a negative 15x, wouldn't it? And plus 27. Now I want to highlight something. You have this minus sign, don't we? It's like a distributive property there. So we got to be careful with this. All right, so we got 2x minus 9, 4x. So this is really going to be 4x squared minus 2x squared. I'll write this out. Plus 15x minus 27. So I'm going to go one more line on this. Combine like terms carefully. I did that wrong right off the bat, didn't I? 4x squared minus 2x squared is 2x squared plus 15x minus 27. And that might be the end of that problem. Now, we may be able to factor that expression up there. So we got to do a little bit more work with this, I think. Okay, everybody, we're going to try to factor this. We'll do a slide divide. I'm trying to think, do we have two numbers that are going to multiply to give you negative 54 and give you 15? All right, so let's pause this for a moment and think about that. Yeah, so I think that we can do that. Had to pause and think about that for a minute with a calculator, but this expression here can be factored into x and x 18 times 3. And then if you remember, we got to do a slide divide. So we're going to divide those by 2. And what I'm searching for is, will we get a common factor? So this would be x plus 9, and this would be 2x minus 3. And the answer is no. No, you do not. So that was really not even necessary. So we're going to go back and just circle that. So I was just checking to see if there was a common factor that may cancel with something in the denominator. All right, let's try another problem here. Okay, this will be our last one. Let's try this again. So I probably went a step too far in that last problem, but it's always good to check to see if you have common factors. Nothing wrong with doing that. Nothing wrong at all. Okay, so my numerators will be x plus 5 and x minus 2. And we do have that subtraction sign to contend with, so that's something to be aware of, that's for sure. Okay, let's go ahead and compare denominators. There's the first one. There's the second. What do you notice is different? The x's, right? So we got to have a times x. The next denominator, right there. Let's compare that to the other denominator. What do you know is different? How about the x minus 4? So I think we're gonna have a similar situation where we gotta be careful. We gotta do a little FOIL method here. So I give myself a little bit more room. Okay, up top here, we're gonna have x squared plus 5x. And this one, we can do a little FOIL method. So that'd be x squared. It's gonna be minus 4x minus 2x. That's gonna be minus 6x, isn't it? And then plus 8. And then keep in mind, that minus sign is going to distribute all the way through there. So our final answer is going to be x squared minus x squared. So those cancel out. 5x plus 6x would be 11x minus 8 over x minus 4 times x. And there we go.